Hello everyone, and welcome to another tutorial video. Okay, so in this video we'll be treating integration by parts. So in our previous videos we took time to treat introduction to integration, indefinite integration and all that. Okay, so in this video we'll be basically treating integration by parts. Now, in case you are new to this channel and you want to see more of these videos, I'll urge you to subscribe to the channel, turn on your post notifications so that you don't miss out on future videos. Like the video, share, and in case you have any question throughout the video, just let us know in the comment section and we'll reply to them as soon as possible. Now, so in simple terms, let me just put this in simple terms. Integration by parts, okay, is similar to what using the product rule in when it comes to differentiation, okay. But what you usually do is just break the integral to its lowest term, okay. So if this still sounds confusing, let's go through the entire process. After that, we solve simple questions so that you get to understand. But the main point is trying to differentiate, okay, to break the expression into its simplest form by parts, okay. So maybe you take u and v, okay. So that's why we have the by parts over here, okay. You integrate respect to u and then you integrate respect to v. After that, you sum them up, okay. That's why initially I stated that it's similar to the product rule when it comes to differentiation. Now, so using the product rule, so you already know the product rule. That's for differentiation. So we have two functions multiplying each other, okay. So let's say it could be x, okay, and then maybe y, okay. And let's say, let me use a proper example. So let's say x multiplying maybe x squared plus 1, okay. So this is product rule. So you could just put or just make this x u and this x squared plus 1 as your v. Note that the u always has to be a terminating function, okay. It has to be a terminating function. I'll explain that when we go further. Now, so we have d dx, okay, that's uv. The product rule, this is just a simple product rule, okay. So we have the u multiplying the v dx. So that's where you differentiate v with respect to x, and then you add that to your function v. So that's x squared plus 1, and then you multiply that by du dx. That's where you differentiate u with respect to x. Note that u and v are functions of x, okay. That's why we have du dx and dv dx. Just like here, x is function of u, or u is a function of x, and then v is also function of x. Now let's proceed from there. We have integrating throughout with respect to x. Now, since we have the expression with respect to x, okay, u with respect to x and v with respect to x, you can integrate the entire expression, okay, with respect to x. So when you do that, that's where you have uv, okay, that's the product, okay, over here. Then we have the integral of u dv dx, okay, as the reference, okay, but we are just integrating with respect to x, and then you sum that, or you add that the integral of v du dx. So it's similar to the product rule, but for when it comes to integration, you just introduce the integral sign, and then you add dx. The same applies here, the integral sign, and then you add here. So this is what I mean. So we have the integral sign, okay, just the integral sign, and then you add your dx, and then your integral sign, and then you add your dx. That's what this simply means, okay. Very, very simple. Now let's proceed. So let's try rearrange this, okay. So in rearranging this, you notice that we need this expression, okay. We have to make this one the subject, okay. The integral of u dv dx, okay, dx, that the subject. So from there we have this entire expression. I'll go into solving problems so that you get to appreciate what I'm trying to explain, okay. So making this the subject, okay, making the entire of this the subject, we end up with the integral of u dv dx equal to uv, that's this one, and then multiplying u multiplying v, and then you subtract that, because when you move the entire expression to the left hand side, it becomes negative, okay, due to this positive sign. Now we have the integral of v du dx and then dx. So in simple terms, you could just write this entire expression, okay, in this form, okay. So this is what I want you to keep in mind. Keep this equation in mind, okay. This is what we'll be using. This is what we'll be using throughout our calculation, okay. The integral of u dv, okay, equal to uv minus the integral of v du. keep that in mind. So that could also be written in this form, okay? Could be also written in this form. So this is the same as this one over here. So all you need to do is just keep one in mind, but I would advise you to keep this expression in mind, okay? Because this is straightforward, right? So let's look at what terminating functions, okay? So terminating functions are functions like x squared, okay, s cubed. Those are terminating functions, okay? And then note that u, whenever you are choosing the u, so from here you notice that I chose u to be what? X, okay? X is a terminating function, okay? It's a terminating function. That's why I chose that as u. Your u, when choosing u, it has to be what? A terminating function, okay? So from here we have what? Note u should be a terminating function such as what? X, s squared, and the rest. So once you don't choose your u to be a terminating function, you find it difficult to solve these kind of problems, okay? You find it really difficult to solve these kind of problems. Now let's take an example so that you get to appreciate the concept of what integration by parts. So let's say you'll be solving two questions, okay? The first one is straightforward, the second one is a bit tricky. So I'll urge you to watch till the end of this video so that you get to understand the whole concept, okay? Getting a portion of the concept will cause more harm than good, you know? So try to get the whole concept of this what tutorial video. Now, so we have the entire expression to what x, okay? What x sine of what x dx. So note that this, okay, this expression is the same as what u dv, okay? This are u dv, okay? This is our u dv. Keep this in mind because we are come to find what uv minus what the integral of v du. So this main expression is our what u dv, okay? Now let's find what our u and v. Note that our u has to be what a terminating function. So from here, which one is the terminating function? Most definitely x is the terminating function. And then let's choose our v to what sine of what x. Now let's find what du dx, okay? Let's find du dx. Okay, so du dx is just like differentiating u with respect to x. So when you differentiate x, you end up at what 1, okay? And then let's make dx the subject. So when you make dx the subject, we have what dx being equal to what du, okay? Right, now after that you have to take the integral of what the v. So for the u you just have to differentiate, and for the v you take the integral. So let's take the integral of this function, okay? So when you integrate sine x, okay, you end up with what minus cos x. You need to know these trigonometric integral functions, okay? You have to know them, right? Once you know them, these integrals will be a bit easier for you. So once you do the reverse, you end up with what this one, okay? Right, now let's use the main formula again. So we are just implementing this formula. So we know that the main formula is what the integral of u dv, okay, being equal to what uv minus what the integral of what v du. So now we already know that our u dv is this expression, okay? Now let's insert our u and v. So u is what x over here, okay? This is our u, so u is what x, and then v is what minus cos x. Note that this is not your v, okay? This is your v because we want the integral, okay? This is our v, so we'll just insert that over there. So we have what minus what cos x, and then minus what the integral of v. So v is also what again is what minus cos x, and then du. So now from here we know that du is what dx, okay? Du is dx. From here we just made du the subject over here, and then we had what du being equal to what dx. So we'll just introduce that over here. Now let's proceed from here. So we have what, so when you multiply this you end up with what minus x cos what x, okay? Very simple. And then when you just solve this, let's just remove this negative sign, okay? So we end up with what positive integral of what cos x, okay, dx. Now we are about to solve for what the integral of what cos x, okay? So let's solve for the integral of cos x. So we have what minus x cos x. Now when you integrate cos x, okay, when you integrate cos x, as I stated earlier, it's just the reverse. You end up with what? Sin x. Okay, you end up with sin x. So we have what? Sin x, and then you introduce your what? Constant. Okay, so this is the what? The final solution for what? For this question. You can notice that this was a bit simple. Okay, so first you just have to find your u, which is a terminating function. You differentiate that, and then you make what? Du the subject, just like here, and then you find your v, you integrate your v, and just after that you just substitute that into the main formula. Okay, this main formula. That's why initially I stated that you need to keep this formula in mind. So just you have your u, which is what? X, and then v, which is what? Minus cos x over here, and then minus or the integral of u v, which is what? Minus cos x, and then du, which is what? Ds from here. Okay, and then you just try expand. So you just bring what? You multiply this, you end up with minus x cos x, and then you just multiply the negatives to get positive. Okay, and then you maintain that. After that, you integrate cos x. Okay, and then you end up with what? Sin x. And so this will be your final answer for this question. So now let's move on to the second question, which is a bit tricky. Okay, so this is our next question. Okay, trust me, this question is a bit tricky. You need to pay rapid attention in order to understand. Now let's proceed from here. So let's look at how we solve this question. So the same principle implies finding what? U and v. So our u over here is what? Terminating function. So the terminating function over here is what? X exponent 3, and then our v is what? Most definitely e exponent x. Now let's find what? Du dx. So we have what? Du dx will give us what? 3x squared. Okay, and then let's make du the subject. Okay, so we have what? Or let's make what? Is either you make du the subject or make dx the subject, but in this case we always make what? The du the subject. Okay, so we know that du will most definitely be what? 3x squared dx. Okay, so this is our what? First equation to keep in mind. Okay, this is our first equation to keep in mind. Now let's proceed from here. Let's find the integral of what? E exponent x. So finally enough, when you take the integral of e exponent x, you end up with what? E exponent x. Okay, so now let's put that main expression into the main formula. So we have what? uv minus what? The integral of v du. Okay, which is what? The integral of what? U dv. Okay, so let's proceed from there. So now we know what u is. Okay, u is what? X exponent 3. Okay, so we have what? X exponent 3, and then multiplying what? The v. So v is what? E exponent what? X. Okay, minus what? The integral of v. Now v again is what? E exponent x from here. Okay, not here. Take note. I'm taking the v from here. You don't take the v from the main one. You take the v from what you've already integrated. So we have what? E exponent x, and then we have what? Du. So now du is what? 3x what? Squared dx. Now from here you could notice that we can just simplify this further to what? E exponent 3, and then what? X exponent 3. Okay, let me rewrite that. It looks a bit messy. Okay, so we have what? E exponent 3, x exponent what? 3, e exponent x, and then let's integrate this. But you could rewrite this as what? From here, okay, you could just rewrite this as what? S exponent 3, okay, e exponent x minus what? 3 out, okay, and then you keep what? E exponent x, s exponent squared. Okay, so the same thing applies. So we are using this right now. Okay, so we have what? 3 out. So let's try what? Integrate this expression. Okay, so we have what? E exponent x, and then what? S exponent what? Squared. So when you try integrate this, you end up with another complex what? Expression. Okay, try to pay attention. Okay, try to pay attention to this portion of what? The tutorial video, because this is where it gets a bit confusing. Okay, right, so we have to take the integral of this portion. Okay, you have to take the integral of this portion. Okay, right, so we have to take the integral of this portion. That's the right hand side. Okay, now we all we have to do is just repeat the same process. Okay, we find our u and then find our what, v. That's for this portion. That's for the right hand side. So we have what, our u, which is what, the terminating function. So the terminating function over here is what, s squared, and then most definitely our v will be what, e exponent x. Now let's find what du dx. So du dx, okay, is equal to what, 2x. This is du dx. Now let's make du the subject. So making du the subject, we have what, 2x dx. Note that we are working only the right hand side. Okay, this is where we are solving. Okay, or this is what we are solving. Now let's find what the integral of e exponent x. The integral of e exponent x is what, e exponent x. So sometimes it wouldn't be e exponent x, it could be tan of x, it could be sine, it could be cos. Okay, it could be any function. Just make sure that you know what you are doing. Okay, so now from here you can notice that we've been able to break this down again. So again, this is what you do. We maintain this. Okay, we maintain this expression, which is s exponent 3 and then e exponent x minus 3. Okay, minus 3. Okay, and then we use the main expression again. We use the main expression, which is this expression. Okay, this expression uv minus what, the integral of what, v du. Let's do that. So uv, so we know that u is what, note, don't be confused, this is what we are solving. Okay, this is what we are solving. We are solving the integral of what, e exponent s squared. Okay, and then we use the same principle for what, integration by parts, to find what, our u, our v, and then what, du. So all we are doing is just substituting the entire of u, v, and what, du with this formula. Okay, with this formula. Okay, this is the main formula we are using again. We are just repeating the process for the right hand side, for this right hand side. So we have what, u, which is what, let me use another color so that you get to appreciate what we are doing. So we know that u is what, s squared, and then v is what, e exponent what, x minus the integral of what. Note, we are using this formula. Okay, this is the formula we are using. So v du. Okay, so we have what, v, which is what, e exponent x, and then du. These are du. Du is what, 2x dx. Okay, just close the brackets. Now from here you could notice that this is a bit complex again, so we have to break it down. So that's why initially I stated that when you get to a certain portion, you need to break the integral down. Okay, try break the integral down. So we have to break this integral down again. Okay, but from here you could just try simplify this. Okay, so when you try simplifying that, you end up with what, this expression remains the same, and then we have what, minus 3 remaining the same, and then we have what, x squared e exponent x, and then you have what, minus what. So bring the 2 outside. Okay, and then you maintain your integral, and then you have what, x dx. Okay, so this is a bit simpler right now, so you could just solve it. Okay, but first we need to break this one down. Okay, we need to break this side of the equation down. Okay, break this side of the equation down again. So when you want to do that, you just have to choose your u and v again. Okay, so for this portion we have what, our u, that's the terminating function, which is what, x. Okay, and then we have our v, which is what, again, u exponent x. So let's find what, du dx. Okay, du dx will give us 1. When you simplify that, you end up with what, du dx multiplying 1 giving us what, dx. Okay, and then let's find what, the integral of what, e exponent what, x. So the integral of e exponent x is the same as what, e exponent x. That's very, very simple. Now let's substitute that into what, this portion, which is what, uv minus what, the integral of what, v du. Okay, right, so let's rewrite the entire expression again. So we are starting from here. So we have what, s exponent 3 e exponent x. Okay, that's this one, and then we rewrite this portion. Okay, so that's what, minus 3, and then you open your bracket, you have what, x squared, and then you have e exponent x. Okay, and then you have what, minus 2. So now let's insert this expanded portion of the what, expression. So we have what, uv. So u is what? X, okay, x, and then v is what? E exponent what? X minus the integral of what? V. V again is what? E exponent x. That's from here. This is what we are expanding, and then you have du. Du is what? Equal to what? Dx over here. So we have that. So you could notice that this has become well simplified. Okay, so from here we can now solve. So we have what? S exponent 3 e exponent x minus what? Let's bring the 3 out, and then we have what? S exponent 2 e exponent x minus what? 2, and then you open the brackets. You have what? X exponent x, okay, x times e exponent x, so that's this one. So minus, let's take the integral of e exponent x. So when you take the integral of what? E exponent x, you end up with what? E exponent x, okay. So we end up with e exponent x. So you can choose to ignore the plus c, okay, or you can just bring it. Most definitely you will need it, okay. Now let's proceed. Okay, so what we are left is what? To just expand, okay, just expand, do the expansion. So we have what? X exponent 3 e exponent x minus what? 3 out. So let's expand what's in the bracket first, okay. So from here we have what? When you multiply 2 by this expression, you end up with what? 2x exponent what? X, and then you have what? Plus what? 2e exponent x, okay, and then you add your what? Constant, which is c. Now let's do the further expansion. So we have what? S exponent 3 e exponent x minus what? So we are multiplying minus 3 throughout, okay. When you multiply that with this one, you have what? 3, okay. This doesn't look like a 3. Let me just rewrite that. So we have what? 3 s squared e exponent x, okay. When you multiply minus 3 by this expression, you end up with what? Positive what? 6x, okay, e exponent x, and then when you multiply 3 by this expression, you end up with what? Negative what? 6 e exponent what? X. You have what? Plus c. Now you could just end your what? The entire what? Calculation over here, or you could just notice that we have the common term, which is what? E exponent x. So you can just factorize e exponent x out, okay. So you have what? E exponent x, open bracket. So we are just factorizing e exponent x from this entire what? Expression, okay. So from here we have what? S exponent 3, okay, and then you have what? Minus 3 exponent x squared, and then you have what? Plus what? 6x, and then you have what? Minus what? 6, okay, and then you add your constant c, right? So this brings us to the end of this video. I hope this video was helpful, because this breaks down the entire what? Concept of what? Integration by parts, okay. Once you understand this video, you are good to go. In case you didn't understand this on the first attempt, just go back to the video, re-watch it, and then you get to understand, because it's very, very simple and straightforward. So I'll see you in our next video, where we'll be treating where we'll be using the calculator to solve integration, okay. You can actually use the calculator to solve both definite and what? Indefinite integrals, and then this form of what? Questions, okay. Right, so I'll see you in our next video. Have a lovely day. Bye bye.